Okay, let's dive right into this. Welcome back, future CPAs. Listen, if you're a BS accountancy student staring down the barrel of the Management Advisory Services section of the board exam, you are in the exact right place. Today's explainer is all about cracking the matrix of linear programming. We're going to transform these complex, multivariable mathematical models into high-yield cheat codes. Because honestly, this is all about working smarter, not harder. We've specifically structured this to build cognitive associations step by step, matching exactly how your brain works. We want to ensure that elusive 3-year retention span so you can completely dominate Quiz 10 and ultimately the LECPA. So, here is our roadmap for today. 1. Cracking linear programming. 2. The graphical method. 3. Corner points and isolines. 4. The simplex method. 5. Sensitivity analysis. And 6. LECPA rapid review hacks. Section 1. Cracking linear programming. So the absolutely crucial point here is this. Linear programming is always about having a very specific goal while dealing with very strict limitations. You're either trying to maximize something good, like your total contribution margin or profit, or you're trying to minimize something bad, like production costs. But obviously, you can't just produce infinite units to make infinite money, right? Because you're bound by constraint functions. We're talking things like limited machine hours, a super strict materials budget, or minimum production requirements. Section 2. The graphical method. I want you to really use active recall here. Imagine you're a factory manager. You only make 2 things. Let's call them product A and product B. You have incredibly limited time and materials. How do you mathematically visualize the exact perfect combination of those 2 products to make the absolute most money? Well, you do it by graphing it out. I want you to literally mentally picture a standard graph with an X and Y axis while we read these steps. This non-image translation is actually going to build way deeper cognitive pathways for your exam retention. Okay, step 1. We take those constraints, like, say, machine hours must be less than or equal to 240, and we treat them as exact equals. Step 2. We find exactly where those lines hit the x-axis for product A and the y-axis for product B. And finally, step 3, we literally draw the lines connecting those intercepts to fence in all our possibilities. Now, that fenced-in area has a very specific name: the feasible region. It's the shaded area on your graph where every single one of your constraints overlaps perfectly. Every single dot inside this shaded shape represents a product mix you actually have the resources to pull off. But, and hey, massive trap alert for your multiple choice questions here. Any coordinate even slightly outside this shaded region is considered an infeasible solution. If a mix requires 241 machine hours and you literally only have 240, it's out. Section 3. Corner points and isolines. So there are 2 ways to pinpoint the single best option inside our shaded region, and this brilliantly illustrates the beauty of linear math. Both of these methods will mathematically yield the exact same optimal coordinate. The corner point method is basically brute force. You calculate the profit at every single outer corner of your shaded shape and just see which number is highest. The isoprofit line method, on the other hand, is way more visual. You draw a theoretical profit line and keep pushing it outward, totally parallel to itself, until it barely touches the very last tip of the feasible region before leaving it entirely. That last touching point, that's your golden ticket. Burn this concept into your memory. The mathematical theory of corner points states that the optimal solution will always lie at a corner or extreme point. It is never, ever going to be floating randomly in the middle of the shaded area. When you're sitting there taking the LCPA, if a question asks where the optimal mix is found, you instantly look for the words corner or extreme point. It is an absolute unbreakable rule of linear programming. And the shape of that feasible region completely depends on your objective. If you're maximizing profit, your constraints are usually less than or equal to your limits, meaning the shape is bounded outward, basically trapping you closer to 0. But if you're minimizing costs, like, say, figuring out the absolute cheapest mix of turkey feed that still meets minimum nutritional requirements, your constraints are greater than or equal to. This means the region is bounded inward, pushing away from the 0 origin. The whole shape literally flips. Okay, here's the million-dollar question. The X and Y axes work beautifully for product A and product B. But what if you're a massive airline managing 500 airplanes, thousands of crew members, and hundreds of routes? You can't exactly draw a 500-dimensional graph, right? Section 4. The Simplex Method. So when you surpass 2 decision variables, you leave the graph paper behind and enter the matrix. The Simplex Method is a methodical set of algebraic instructions that examines corner points mathematically without ever needing to plot them visually. Now, breathe a massive sigh of relief here. You will not have to execute a gigantic simplex matrix by hand on the board exam. But you absolutely must know the definition. It is the algorithmic method used when you have more than two variables.
Section 5. Sensitivity Analysis.
Sensitivity analysis, which is also called post-optimality analysis. Look, operations managers live in the real world. What happens if the cost of raw materials suddenly jumps by 10%? Or what if our available machine hours get slashed because of a random power outage? Sensitivity analysis tells us exactly how much these input parameter changes will actually alter our final optimal solution. Let's test your understanding real quick with a classic LECPA-style question straight from the review materials. If your constraint is 6x plus 4y is less than or equal to 30, you can't run an algorithm on a less than sign. What do we mathematically add to the left side to turn that into a firm equals 30? Now, what's really interesting about this is the concept of leftovers. The answer is a slack variable. Think about it. If you use 28 hours out of your 30 available hours, you have 2 hours of slack. Adding a slack variable fills that gap perfectly so the equation actually balances out. In operations, a slack variable basically just represents your unused resource capacity. And speaking of resources, we absolutely have to talk about the shadow price, which is sometimes called the dual value. Flag this in your brain, because it is a massive high-yield concept. The shadow price tells you exactly how much your total profit would increase if you could get your hands on just one more unit of a scarce resource. So if the shadow price of machine time is 5 pesos, it means adding 1 extra hour of machine time will boost your final profit by exactly 5 pesos. It is literally the true hidden value of your limitations.
Section 6. LECPA Rapid Review Hacks.
Okay, I want you to mentally screenshot these bullets for your spaced repetition flashcard apps. This is the exact rapid-fire association your brain needs on exam day. 2 variables? Graphical method. More than 2 variables? Simplex method. Where is the optimal mix? Always at an extreme corner point. What is a slack variable? It's your unused resource capacity. What is the shadow price? The marginal profit change from 1 extra unit of constraint. And what is the ultimate goal of LP? To either maximize profit or minimize cost. Boom. That is exactly how you navigate the multiple choice questions efficiently. Which leaves us with this final thought. You now fully understand the matrix of how companies optimize their incredibly limited resources to achieve maximum success. But honestly, your most scarce resource right now isn't machine hours or raw materials. It's your time and your focus before exam day. Are you going to apply these same principles to maximize your own study efficiency? Find your optimal corner point, eliminate the slack, and go crush that board exam. Thanks for joining me on this explainer, and happy studying.